Our next speaker is Joana Silva from the Faculdade de Ciências e Tecnologia de la Universidade Nova de Lisboa. Joana has completed the master's degree in conservation and restoration with a specialization in photography in Faculdade de Ciências e Tecnologia de la Universidade Nova in 2009. She worked for Luis Pabao between 2009 and 2014 at the library from the Fundação Calouste Gulbenkian. Presently, she's doing her PhD in conservation and restoration of cultural heritage at the same university.
So, good morning. I'm happy to be there today to present you my work. I'm going to present you part of the work I'm doing in my PhD, which focus on the photographic and filmic collection of the Portuguese artist Ângelo de Sousa, more precisely in cellulose state-based chromogenic reversal film. So Ângelo de Sousa is one of the most important contemporary Portuguese artists. He's characterized by an experimentalism that enabled him to achieve exceptional originality. With his death, he left a broad legacy of paintings, sculptures, drawings, and also experimental film and photography. The collection is mainly gathered in the artist house. So I brought you some examples of his works. Here are some paintings and some drawings, sculptures in traditional materials and also contemporary materials, such as plastics, experimental film, and photography. So in all the materials he explored, he frequently worked the idea of color. He frequently used the three primary colors for the use, for example, for his paintings, the subtractive mixture, and for his photographs and films, the additive mixture. Quoting José Gil, Ângelo, through his whole life, did nothing but conceive sets of color movements. He's a colorographer, a painter intoxicated with and addicted to color, a chromo addict. So this is an example of, this work is called Slides de Cavalete from 1978-79. It's a work composed of 100 slides, and it's a perfect example of his interest and knowledge and control about of the primary colors, because to produce these images he exposed the same frame to lights of the primary colors, so red, green, and blue lights, and he creates these amazing images. So before the beginning of the study, there was no idea about the characteristics of the collection, so we decided that the survey would be a priority task. So in order to understand a little bit more about the collection, we try to trace the history of the collection, looking at its background, the house characteristics, and the storage conditions, since almost all the photographic collection is gathered in a single room. We also made a topographic inventory, or an inventory, trying to, in a database, trying to collect as much as information about typology, quantities, organization, and conservation conditions, among other information. So this is the room before the survey. We did also some cleaning and tried to stabilize some photographs we found that were at risk here, and this was the room before the survey. So it is now possible to say that the collection is composed of 85,650 photographs. We can mainly composed of three groups: the negatives, mainly black and white negatives with cellulose acetate base, 35 millimeters. The reversal films, mainly chromogenic reversal films with cellulose acetate support, also 35 millimeters, or slides. And the prints, mainly black and white prints with developing out papers. So, although the collection is mainly composed of cellulose acetate base supports, 84%, no signs of vinegar syndrome were found. Here is the conservation condition of the DOP prints. So basically they present some dirt, fingerprints, silver mirroring, yellowing, curving, so they were considered in fair condition. The black and white negatives, well, we didn't find any signs of vinegar syndrome, but the photographs shows, probably due to the handling, they shows a lot of dirt, fingerprints, and also abrasion, and also some silver mirroring and apparently fungi. So they were considered in fair condition. The chromogenic reversal films, no signs of vinegar syndrome were found here too. And probably because the slides were processed in external laboratories, they didn't present, they only present slight dirts and were considered in good condition. Unfortunately, almost 30% of the collection of this set present color change and fading, which was considered a problem. So after surveying all the collection, we considered that this set was the set at highest risk. It is also a representative part of the photographic collection, almost 40%. And as we saw before, color is a very important issue in Ângelo de Sousa work. So we decided to do a material research in order to study chromogenic reversal dyes and its fading. So before I explain the work I'm doing, I'm just going to try to explain briefly what chromogenic processes are. So basically, the chromogenic processes use a subtractive method to produce all the colors of the reality. Initially, before the processing, we have 3 superimposed black and white emulsions with silver salts that are each one of it only sensitive to a specific spectral region. Additionally to those silver salts, there are color couplers that will be responsible for the creation of the yellow, magenta, and cyan layers. So after exposure and during development, the developer will develop silver salts and the oxidized developer will react with those color couplers to produce the dye. In the end of the processing, the silver is bleached and we will only have the dyes in the final emulsions. On the right, you can see these cross sections of chromogenic reversal films, where you can see the yellow, magenta, and cyan layers. And on this image, on your left, you can see the surface of the same sample, and the dye clouds are discernible. So chromogenic dyes generally are susceptible to degradation both by hydrolysis and oxidation, and also other type of reactions may occur. For example, the interaction between the residual color couplers with dye molecules. But basically, both relative humidity and temperature and/or light will cause the fading, the yellowing, and the change in color. So if in these images where we have an identified object of the reality, it may be quite easy to say if we are having color change. In these images, for example, one of the images of Slides de Cavalete I showed you before, it may be quite difficult to say if there is occurring color change. So it is common practice in photography industry and conservation to study dye fading using a densitometer. The densitometer basically measures the optical density, which is a measure of the percentage of reflected light for opaque objects such as a print, and transmitted light for objects such as slides that are transparent. So by measuring the optical density, it is possible to do kinetic studies of dye fading based on accelerated aging samples, and then to estimate the lifetime of a product or compare different products. So in this study, we are proposing to use another analytical technique to study dye fading, which is a UVV spectrophotometer. So the UVV spectrophotometer basically measures the relative amount of electromagnetic power reflected or transmitted at individual wavelengths of the spectrum. Based on Lambert-Beer's law, the absorption is dependent of the intensity of incident light and the intensity of light that passed through the sample. That basically is a measure of the transmittance. And as you may see, the absorbance and transmittance are inversely proportional. So the UVV spectrophotometer will give us a spectra that is basically a fingerprint that is characteristic for a specific material, and also allows us to characterize the color of the material. So from this spectra, we can access the optical density similarly with the densitometer, because in our spectra that you can see, for example here, it is the intensity maximum. So this spectra, gray, you can see 3 different bands. It is a spectra of a slide. You have the 3 bands that correspond to the 3 dyes. So in the blue region of the spectra, we have the yellow dye, in the green region of the spectra, the magenta dye, and in the red region of the spectra, the cyan dye. So additionally to this spectra, we can convert it into 3 stimulus values and then convert them into CLab coordinates. That is basically a measure of the color based on the perception of our eyes. So we can access those coordinates individually or as assessment of the overall color change. Oops, sorry. So this is the UVVs of the university that is being used to this study. It uses optical probes, as you may see there. So we can do the analysis in a non-invasive way in a very small area of the sample. So what is the difference between a densitometer and a UVV spectrophotometer? A densitometer allows us to see the optical density and then to access color levels. And UVV spectrophotometer allows us to access the same and gives us a spectra that allows us to convert this into values such as the 3 stimulus values, and then be converted into a color space such as CLab. And therefore it is possible to access color variation. Also, densitometer is an apparatus that is becoming a little bit obsolete. So in this study, we are proposing to study slides from Ângelo de Sousa collection. And to do that, we have to do an accelerated aging to samples that are representative from the collection. From this accelerated aging, we aim at do a kinetic study of the dye fading and calculate the lifetime of each dye. Therefore, understand which dyes are more unstable, estimate the change in color balance, and predict how the works will change over time. Ultimately, we want to develop strategies or tools to try to restore or reconstruct what was the original image. Also, we want to define a methodology to study dye fading using the UV spectrophotometer. So we decided to use to age those samples, Fuji Provia 400X. And why those samples? Because we found unexposed films in Ângelo de Sousa's house. And we know a little bit what is its story, and they are representative. And this brand is the fourth most representative brand. Oops. Also, the films are outdated, but are still possible to use. So taking into account the ISO standard 18909 from 2006, we will do this aging using two relative humidities, 45%, which is a good practice condition, and 60%, which is the average condition found in Ângelo de Sousa archive. These two relative humidities will be tested at 4 different temperatures, 15, 16, 17, 18 degrees, and also room temperature for comparison. So before doing the accelerated aging, we did an accelerated aging test to test this methodology to a set of duplication slides with images from Armenia. We decided the more aggressive the temperature, 80 degrees, at both relative humidities, and the samples were aged during 42 days. Before so the samples were kept inside dessicators during 15 days, so that the emulsion get this relative humidity, and were sealed inside polyethylene bags, and then were placed inside the oven. So I'm going to present you the results for one sample age in each condition. So sample 1 was aged at 62% humidity and 80 degrees Celsius, and sample 2 aged at 48% of relative humidity. All the samples were analyzed in 3 different areas, and the results were quite consistent, so I'm also going to present you only the results for one area for each sample. Here you can see the results of the scanned image before and after the aging, and as you may see, the images tend to be pinkish with aging, and if you look in further detail, also the image is becoming less sharp. Here you have the spectra from the UV spectrophotometer. We can see the 3 bands from the 3 dyes, and in the line here in light gray, it's before aging, and the dark gray after the aging. So we can see a global decrease in the absorbance intensity. That means that the dyes are fading. This is so globally we can see that in the sample 1, aged at 62% relative humidity, cyan dye was the most unstable, yellow dye followed by the yellow dye, and magenta dye was clearly the most stable dye, and the results are a little bit the same in both the 2 samples. Looking at the CLab coordinates, we can see that in both cases L increased, meaning that the sample is becoming lighter. The A coordinate increased also, meaning that the sample is becoming redder, and B decreased, meaning that is becoming less yellow. The same was found with sample 2, and we may see that in the total color variation was bigger in sample 1, aged at 62%, than in sample 2, aged at 48%. So basically we may say that cyan dye was the least stable, followed by yellow dye, and magenta was clearly more stable than the others. From the CLab coordinates, we can say that the image is becoming lighter because of the fading. That was what was expected. And more red and more blue, so more magenta. And those results are quite consistent with the images I show you in the beginning that are becoming pinkish. Also, we can see an apparent influence of the relative humidity in the dye fading. So with the higher humidity, we have more degradation. We also did a FTIR to the Cellulose state in order to assess if there was any difference before and after de-aging. And although we need to do access more accurately those bands, we may say that there were no considerable change in the base. So for conclusions, I would say that although the collection has so many Cellulose state supports, no signs of vinegar syndrome were found, and we can say that dye fading appears as a problem before the degradation of the support. Regarding UV spectrophotometry, it looks like it is a good technique to assess dye fading in slides, and this methodology may be applied in a serrated aging test. And specifically to the case study I am doing, and maybe to other collections. Thank you for your attention. And sorry, I would like to thank the Foundation of American Institute for Conservation for the funding that allows me to be there today.